Confession time. I made a mistake in an earlier piece of footage. I claimed that this was channel 1. It is not. It goes 1, 2, 3, 4, 5, 6. I'm afraid I got myself into a bit of a muddle because in the documentation it says patch from right to left. And I'd made a wrong assumption that because it's right to left, this was 1, 2, 3, 4, 5, 6. No, so yeah, I had to do a bit of rewiring, dismantle 2 channels and change them around. So here's the finished module. It seems to be working quite well. I have had some issues with it. The first one was channels 1 and channel 6 sliders were inverted. Now, after doing some digging around and looking at the code, the author had actually put a note in to say because the way she laid the PCB out, these 2 channels were inverted. What do I mean by that? Well, basically, the pots have got 3 terminals, a wiper, which is typically number 2, and a 1 and a 3. What I've had to do is swap wires 1 and 3 over for these 2. These were okay. So yeah, all is good. I did consider kind of changing the program, but yeah, I didn't really understand it. It would have taken me quite a while to get into that. So no, I opted for the easy option and just changed wires 1 and 3 on the pot on this one and on this one, and it seems to be working. So if you have a look there, output green flashing, so it's looping and it's in LED mode at that rate, and you can see the trace on the oscilloscope. If I change that pot there, you'll see the shape of that change from a sawtooth wave to triangle, through sine wave, trapezoid and square wave. Winner winner, chicken. So the module pulls about, I don't know, 80 to 100 milliamps on the positive rail and about 20-30 milliamps on the negative rail, so that all seems normal. So let's have a look at the wiring. You're not going to like this, and neither do I, but it works. Let's have a look at the rat's nest. Have a look round the side. And there it is, in all its beauty. So time to get to grips with the manual and learn how this thing works. But what I've managed to do is have a free running square wave LFO, and that is triggering these 4 channels starting here. So it's a ADSR, attack, decay, sustain, release. And you can see it's working there on the scope, so it all looks winner winner, chicken dinner, bring it on. So just one other point. The actual Mutable Instruments module, it uses a gate jack which has some connections inside it. So when you plug in a cable, it disconnects some of the connections inside there. So by default there is something called a normalization signal which is created by the microcontroller. It goes into the gate input when no jack or cable is connected. So I can't do that, so to mimic that behaviour, basically I just flick that switch down and it disconnects that normalization signal from the microcontroller, and then you can feed the gate signal in here. And actually that is of some use, because that means that I don't have to use dummy cables plugged in. I can just flick a switch and have the same behaviour. So actually I think that works quite well. The second point is that switch up there, I've actually connected it. it speaks for itself. At the moment it's in the down position and it's in normal mode. If I flick that up and do a power cycle, it changes its mode of operation to the Easter egg, so we can get some audio oscillators and harmonics going. So that's it for this snippet.